Today's daily LeetCode problem of the day is Defuse the Bomb number 1652. For this problem, you have a bomb to defuse, and your time is running out. Your informer will provide you with a circular array code of length n and a key k. To decrypt the code, you must replace every number. All the numbers are replaced simultaneously. So if k is greater than 0, you are going to replace the ith number with the sum of the next k numbers. If k is less than 0, we're going to replace the ith number with the sum of the previous k numbers. And if k is equal to 0, then we'll replace the ith number with a 0. So as code is circular, the next element of code of n-1, or the last element in our code, is going to be the first element in our code. And the previous element of our first element is going to be our last element. So for the first thing we should probably take note of in this problem is we have a circular array, meaning that we can go past the end of the array and wrap back to the beginning, or go before the beginning and wrap to the end. So this adds a bit of complexity, and we just need to know how to traverse this. So to approach this problem, we are going to use a sliding window technique. And to make sure our solution is efficient, this sliding window technique is going to consistently keep the sum of wherever it's at. So when k is equal to 3, our window is going to be of 3 length. So 5, 7, and 1 are going to be in the window, and we're going to be looking at 4. The reason 5, 7, and 1 are in our window is because after we go from 4 to the next element, it's going to go to 5, 7, and then 1. And these are the 3 elements that we're going to add together to get whatever's in the 4 place, as we can see right here. If we were looking at 5, the window would be 7, 1, 4. If we were looking at 7, the window would be 1, 4, 5, so on and so forth. If k was negative 3, however, and we're looking at 4, our window would be 1, 7, 5, because we're going backwards at that point. But we'll traverse that when we get there. So we need to take precaution for each case, where k can be greater than 0, k can be less than 0, or k can be equal to 0, and take that into account when we're building our code. So let's go ahead and jump in and implement the sliding window. We're going to first start with an integer array called a result. And because we're going to be solving for each part of the code simultaneously, meaning all at the same time, we do not want to change the values in our original code. So that's why we're making a new array. We'll then check if our k value is equal to 0, because if it is equal to 0, we can simply return our result as is, as everything's initialized to 0. Otherwise, we're going to start our sliding window. So we're going to have an integer start. It's going to be equal to 1. And we're going to have an n value, which is going to be initialized to k, and a sum value, which is going to keep track of the sum, which will be equal to 0. We're going to check if our k value is less than 0, meaning we're going to traverse backwards. Then we're going to start is equal to code dot length minus math dot absolute value of k. The reason we're doing this is because we first initialize start and end to the first k numbers in front of our element. By doing this to our start element, we are simply initializing it to be behind our initial element, as we're going to be traversing backwards. And we'll do the same with our end value, which will be equal to code.length minus 1. So we're just going to traverse it backwards instead of forwards. Then we're going to set up a loop, and it's simply going to calculate the sums. So we're going to have 4 int I is equal to 0, as long as I is less than or equal to end, then I can increment. And in this little loop, we don't even need brackets, because all we're doing is sum is going to plus equal code of I. And that is just going to calculate the sum of the elements in our sliding window that we calculated up here. Then we're going to go through our code again, and we're going to slide that window. And we are going to update all the values in our result array based off of the findings we have in our sliding window. So result of I will be equal to sum, since we already calculated the sum. And then sum is going to minus equal code of our start modulus code.length. And that is important to prevent the code from going out of bounds. So if we're starting at 12, let's say, and we go back one element, then we're going to not want to go out of bounds. We're going to want to jump over here. And then we're going to have sum is going to plus equal whatever the new element is at the end of, at the number after n, so end plus 1. And we're also going to modulus this by our code.length to prevent it from going out of bounds as well. Start will then increment, and end will also increment. Then we can return our result. And it's as simple as that. So if we run this, this passes our test cases, and if we submit it, passes all solutions. Thank you. Follow for more daily LeetCode solutions. Check out my Instagram for shorter content, as well as a link to my Discord where you can learn more with me today.